Okay, and you can try it out on the website. There's the demo in there. So this is the easiest way. So if you don't know what kind of input you want to provide, so it's automatic segmentation. The second one is called use points as input prompt. So you can think about the first one is unsupervised classification, but it's for doing segmentation. The second one is this one is called kind of a hybrid, kind of a supervised classification. You give some points, and then you based on the points to extract the object you want. So in this case, right, you have all the horses. You can just pinpoint some of those, and then you're going to extract similar objects because you are the one providing the points. So you probably know it's horse. That's why it's kind of a indirect way of figuring out the label for the objects. Okay, the first one doesn't tell you anything. The second one here is more like indirect of getting the label. You can also use the bounding boxes, something like this. So you can draw a bounding boxes, and it's going to guess what you're going to extract. So most likely the larger object, the largest object in that bounding boxes. And you can draw a bounding boxes around several objects, and then you're going to extract those objects very much similar. So this is using bounding boxes. And the last one here is called text prompt. So you can basically give a text description. For example, I want to extract the cat. I want to extract the dog. It will extract it for you, but keep in mind this one is not released by Meta. So it mentioned this capability, but it's not implemented. So we use grounding Dino actually implement this one. So it really works. So I will show you some examples later. And so this is kind of output, like given imagery. You're going to give you 3 output masks. And like I said, you don't have the label. You don't know whether it's horses or dogs or anything. It's objects. So it's up to you. If you provide the point, you know it is the label. So it's basically a great way of doing the segmentation. So you can look at the example here, something like this. So for example, look at this column here. Maybe your purpose might be trying to extract the person, or you might be extracting the backpack, or it might be a part of a backpack. So that's why it's ambiguous. So the model give you these 3 outputs, and you pick whatever you want. But you can also use default one, the highest probability. It's up to you. But just let you know, you have 3 options in the output mask. And this is data set that is used to train the model. So basically, use that to train the ChatGPT that you can use. And it's called SA1B. So segment anything model, 1 billion mask built on top of 11 million images collected around the globe. So basically everywhere. So it's a mix. But like I said, this is not any single imagery is from remote sensing, not from satellite. It's just like JPEG and PNG images. And each image on average has 100 masks. So basically give the imagery and then have the mask and then use all these images to build the foundation model. And you can see the graphic geographic distribution of the imagery. Where do they come from? This make sure that it has a representation from everywhere. So they can really do anything, segment anything, okay? Because it's supposed to be generalized to do things that you have not seen before. So you need to actually have a variety of landscapes so that you can identify. But again, doesn't know what it is, just to group similar pixels into the same object. And so they released the model last April, but they didn't make a kit package or contact for us. So I actually spent some time build this one, make sure that it can be easy installed by Python users. So I published the package on a PyPI and also contact was that. So just with one command line. And this is how I'm going to use it. So the model has 3 options, VIT, L, and B. So you can see the size is different. So the largest one is 2.5 gigabyte and the smallest one is 15. Kind of like the Google Gemini model, Gemini Ultra Pro, and also Nano, right? So different user cases. If you really have the GPU, then you can use the largest one. It's going to give you the best result. But if you have limited GPU resources, you can use the smallest one, or you can use a mobile phone other applications. So basically, you have 3 options, and then you can just use 2 different modes, automated, or you can use the so-called predictor, means you provide some points, you provide some bounding boxes, or provide some, and then you do the segmentation. This is how it's being used. We don't have time to get into detail, but if you want, you can try it out. But specifically, what we're going to do here in this talk is how can we leverage this model for doing segmentation geospatial, because we have a lot of satellite data and the task is very much similar. We want to extract objects from the satellite imagery. but the model is not trained on satellite imagery. How can we expect it? So I created this one roughly 1 month after they released the model, so it's only almost like 1 year old. It's pretty new, but it's one of the like packages that quite popular in the geospatial community. It gets like 2 to 3 thousand stars that usually took me a couple years to accumulate, but this one was like, yeah, kind of a lot of people interested in using it because there's so many applications. And I also published a short paper describing the package in JOSS journal. And similarly, you can install just one line, the package on PyPI and also Condaforce. That makes it easy for people to integrate into their workflow. Next, I'm going to quickly go through some key features. The first one is called fully automatic segmentation. So basically, give me a satellite imagery, I give you the object and give me all the segmentation. So you can see this example here. I think this is UC Berkeley campus, if I'm not mistaken. And then you automatically segment all the objects, all the building, everything. Very colorful. Like I said again, it doesn't know it's building, it's just object. It's similar pixels grouped into same object. But you can do some post-processing to extract the buildings. But this is very easy to do. And all the example I'm going to show you here has a link, a notebook you can open in Google Colab, and then you can use the, thanks to Google Colab, the free GPU. So you can run the GPU, you can run everything on using just a browser. And pretty cool because you can do it for all kind of images. And pretty just a couple lines of code. So it's very, very easy to use. And the output can be saved as geospatial format. So output GeoTIFF, or you can also vectorize to vector data format, JSON or whatever vector data format you want. So this is called fully automatic segmentation. And again, it's not perfect because most likely you want to know the label. You want to know the buildings, you know the trees. And similarly, for example, this one here, you can segment buildings, greenhouses. It's pretty good. So this one is using the point. So for example, I want to extract the buildings. You can click some points on the map, and then you will just use the input prompt. And so SEMGeo has the interface, allows you to do things interactively. Pretty much, you don't need to do any coding. You can load any imagery, and then just click a couple points on the map. You will extract all of them. So the building, for example, if it's not perfect, you can place some background points to remove the background. Then we get all the buildings. So you can see here, I don't place the points on all the buildings. We'll be able to detect other buildings. And the result can be saved as GeoTIFF or vector data. You can also do bounding boxes. So if you have bounding boxes from other deep learning models, you can use the bounding boxes as input to inform the segmentation. And so, for example, you need to extract all the trees for the neighborhood or for the county, whatever. You can, if you already have the model, you can use that as input, and it's so much better. So imagine if you're doing that manually, trying to delineate the trees boundary, it's going to take you days, hours. This is seconds. Very responsive. You can do some kind of batch processing to check all the trees pretty easily. The last one here, this is text prompt. So this is even cooler, no coding. Give a set of images, just type, I want the buildings, it give you the buildings. Type the tree, give the trees. It's up to imagination. You can try it out. It's not going to be perfect, okay? It's automatic. It's going to need some trial and error to figure out the optimal parameters, but it saves you a lot of time. So if you're someone trying to do some prototyping, you want to extract something to try to see if it works, you can try it out, load the imagery, and just type a command. In seconds, you get a result, right? So you don't need to build a model, you don't need training, you don't need anything. It was fine, but just because it's not going to be able to solve everything. And for example, I'm interested in the neighborhood. I want to figure out how many swimming pools, right? I just type swimming pools, and you can basically convert to vector data and then load it into other GIS software if you want. Everything is very interactive. Pretty much no coding. Again, you can try out. So last one is if you want to do a large area. So this is so-called batch segmentation, because the model does require a lot of GPU, limited resources. For working on a large area, then you need to subdivide the images into smaller segments, and then you do segmentation individual one, and then you can merge the result all together. So the SEMGeo also has the batch segmentation mode that if you want to use it, you can process a large image. So for example, I want for the trees for city. Yeah. So also do some beauty extraction. This is something that you can utilize if there's any disasters. So if some images, for example, high resolution images before and after, you can quickly use this one to figure out how many buildings we're going to damage. Again, it's not going to be perfect. You need some post-processing, but it's still so much faster than you trying to build a model yourself or trying to delineate manually. It's going to save you a lot of time. And you can use all the tools to do some comparison of the data before after. This used to take a long time because this one is the it's the Libya flooding. So it took a couple of days for Google and Microsoft to release the new building data, but the imagery always comes before. So the analytics usually comes lag behind. But now this is that everyone can have it on using your computer, just use browser access to the data. Lastly, here are some additional resources. So if you're interested in learning more, SciGeo is only a side project that I developed. There are a lot more here in the open geospatial solution that packages that I created and developed during the last couple of years. It's all free, open source. You can use whatever way you want. And SciGeo actually I only spend a little time, mostly on Gmap, LeafMap, some are more like on visualization. But when I have time, I try to add more features into more analytical functions into those. Welcome to try out this one. And also, I do have a YouTube channel teach people how to do mapping, geospatial, and also open source Google Earth Engine cloud computing database. So you're welcome to check out the YouTube channel. And here are some of the related tutorials for specifically for SciGeo. So if you want to learn more, you can also check it out. Lastly, some of data. So if you need some open data, high resolution data to do segmentation, you can try out. So the MaxR open data catalog has a lot of nice data for doing disaster management. So you can use that to do segmentation if you want to. And there's a huge data catalog, but it makes it easy for you to visualize. So you can use some of the web data created, see what the data looks like, and then you can download the data to fit into the model. So, and here's some of the web data created using Solana also that allows you to go anywhere. Whenever they have some disaster, so you can, this image is available, and you can see it, and you can just download it and then fit the model to segmentation. Similarly, right? So this one is the earthquake, Morocco earthquake. There are tons of images out there. There are a lot of data, but they are not fully being fully utilized. So it'd be great people can develop this and make things more accessible, and also make the model accessible that everyone can develop, delineate the feature that we want from these images and help with the disaster response. And that's all I want to share with you. I want to point out that I don't really create anything new. I'm just utilizing the existing one, but makes it easy for people to, and so that people without the technical skills, they can utilize this stuff and also they can contribute. Thank you very much. Huh? Yes. No, you don't need the type. You can input basically read the div and then you convert into array and then you fit in same thing. There's examples on if you click the notebook and then there's some code block that replace your own imagery. Otherwise, you use the sample image. Converting back to GeoTIFF with georeference. So basically, input the georeference, GeoTIFF, you output the GeoTIFF, and also optional, you can vector data. It's all georeference, so you can overlay on top of the imagery. So behind the scene is because the segment NEC model is only accept X-array, basically row and column. They don't have georeference. Under the hood is giving the GeoTIFF and then calculate the row and column and fit into the model, get back out with the row and column, and then put it back to basically add the projection. Of course, yeah. Okay. No, but GPU usually is going to be 5 to 10 times faster. But still, you can run a CPU. It's just like similar to any deep learning models. You can run CPU, you can run GPU, but of course, GPU is dedicated, it's much faster. No, you can use Python script, so you don't need to use interface. So basically, it's just like read imagery and then segmentation. So if you have the point, improve. So everything you see the interface, everything there's a function being called to execute. So you can do that without the interface. Oh no, you don't need to. It's automatic. So under the hood, if you detect the GPU, you will use the GPU. But you can also specify the device. Let's say I want to use the CPU, and then you use the CPU. Yes. That one you probably use the original Segmentation model because I guess you don't really have those geo reference and also the projection stuff that usually have in the GOTs. So you can probably just read the data and then read into an array and then you can fit into the original model. So right now the SenGeo doesn't have that functionality, but there is something that I can add is to make it more generalized that people can still use it to segment any images without the short answer is not yet, but yes, it's on my to-do list. It's most requested features, and I already have some example, but I haven't really implemented yet. So hopefully, will be coming sometime later this year. I have no promise. I only have one person, so you're welcome to contribute. Anyone know how to do that? You're welcome to contribute to the source code. And I'm also trying to get some funding from NASA to have support that I can spend more time. But like I said, this is my side project, it's not my main project. So I didn't spend too much time on that. But this is certainly something that I'm have been on my to-do list for a while. Yeah, that's also a push request that's already been about it. So right now it's not possible yet because we use the original segment NC model, so it's only the three bands. But temporary solution would be you select any three bands and into the segmentation, you select another three, and then eventually you can combine the result together. Ideally, in the future would be you don't need to do that. Just give me whatever bands, put into that, and then you can do the segmentation. And I'm also hoping to add some hyperspectral so you can be 100 bands into that, and then you can do the segmentation automatically. And again, if I get the NASA funding, I'll implement it. I'm sorry, I need to go back tomorrow. So I have to, but yeah, I'll here slow flight. Yeah, yeah, feel free. You can find my URL, and I'm on social media very often, so you can always find me or Google my name. So, and you can also look at the GitHub repo and submit issues, bugs, or feature requests, and you usually receive response within 24 hours. The customers Thank you.